Here's example 3 on sketching rational functions. First thing to do, factor anything you can factor, and I can see that I can factor the numerator. They have a common factor of 4, so I can factor out 4 and get x minus 3. And the denominator stays the same. There's nothing to factor there. Okay? First step is find the y-intercept. Y-intercept, remember we evaluate the function for 0. That gives you 4 times 0 minus 12 over 0 minus 1, which is equal to negative 12 over negative 1, which is equal to 12. That means that the y-intercept is found at the point 0, 12. Okay? What else? Number 2 is find the zeros, or the x-intercepts. And to do that, we're going to use the numerator. My numerator says 4, x minus 3, and we equal it to 0. Now, since I have a 4 here in front, I can divide by 4 on both sides. And that way I'll eliminate this 4, and I'll get x minus 3 equals 0, x equals 3. I only have 1, 0 for this function. Number 3 is the vertical asymptote. We're going to take the denominator for that and equal it to 0. That means x equal 1 is the vertical asymptote. Number 4 is the horizontal asymptote. And for this, we have to look at the degree in the numerator, the degree in the denominator. Notice that the degrees are equal. So what do we do when the degrees are equal? That means we take the leading coefficient of the numerator and divide it over the leading coefficient in the denominator. So the leading coefficient in the numerator is 4. This is the horizontal asymptote. 4 over 1, because the leading coefficient in the denominator is 1. So that means that the horizontal asymptote is found at y equal to 4. Y equal to 4. That's the horizontal asymptote. And now we're going to do the sign analysis. To do the sign analysis, I'm going to draw a number line, and I'm going to figure out where the graph is, if it's above or below the x-axis. There's my number line, and now I am going to, what am I going to plot on this number line? Remember, we're only going to plot the zeros, this information, and the vertical asymptotes. That's all I'm going to plot on here. So I only have one 0. Let's say x equal to 3. Let's say it's right here. X equal to 3. And I have a vertical asymptote at x equal to 1. So here's a wall at x equal 1. And notice that these 2 points, which are critical points, they divide this number line into 3 different intervals. Here's one interval from negative infinity all the way to 1. There's another interval between 1 and 3, and there's another interval between 3 and positive infinity. Okay? So I have 3 regions that I have to test. Let's go ahead and test the first region from negative infinity to 1. Let's choose a number. From negative infinity all the way to 1, I think an easy number to use is 0. Okay? So I'm going to use 0. Now let's go ahead and say if I plug in a 0 here, will the result of the numerator be negative or positive? Well, 0 minus 3, that will be a negative number. And negative times positive, that's negative. So the numerator will be negative. If I plug in a 0 in the denominator, I'll have 0 minus 1, and the result will be a negative number. Negative divided by negative, that's positive. That means that this graph comes from above the x-axis. Okay, above. Good. Now let's do the next interval. For the next interval between 1 and 3, I'm going to choose the number 2. If I plug in 2 for x, 2 minus 3, will that be positive or negative? It will be negative. And negative times a positive 4 will be negative. If I plug in a 2 in the denominator, 2 minus 1, that will be a positive value. So I have negative over positive, negative. That means that the graph will be below the x-axis in this interval. And for the interval 3 to infinity, I'm going to choose the number, I don't know, choose any number, 20. If I plug in 20 for x, minus 3, will that be positive? Times a positive 4, that will be positive. If I plug in 20 here, will this be positive? I said 20. I don't remember now if 20 was the number I had. Well, you get the idea. Any number you plug in here that's greater than 3, will this be positive? Positive. And positive over positive will be positive. That means that I will be above the x-axis. Okay? Now, on my graph, I'm going to plot all of the information that I have so far. Let's start with number 1. My y-intercept is at 0, 12. Well, that's going to be hard because I don't have 12 here. I have 1, 2, 3, 4, 5, 6. So I'm going to count by 2s. This is going to be 2, 4, 6, 8, 10, and then this will be 12. So here's my y-intercept. Okay? And next thing are my zeros. Zeros is at x equal to 3. On my x-axis, I'm not going to count by 2s. I'm just going to count by 1s. So here's my 0 at 3. And my vertical asymptote is at 1. That means I have a wall here at x equal to 1. Here's your wall. And what else do I have? I have a horizontal asymptote at y equal to 4. So here's 4. And I'm going to draw a dashed line across y equal to 4, showing that I have a wall that's horizontal. Remember, we can cross and touch the horizontal asymptotes, but not the vertical asymptotes. Okay? And that's it. I have everything I need on my graph. Let's start sketching. So it says on here that from negative infinity, the graph is coming from above the x-axis. And from above the x-axis, since I have a horizontal asymptote, it usually means above the horizontal asymptote, okay? So when I'm above, not only above the x-axis in this region here, I'm also above the horizontal asymptote. And I'm going to be above all the way till I reach that wall, which is at x equal to 1. And we know what happens near the walls, right? Here's what happens. Here's a wall right here. So I know that my graph is going to be very close to this horizontal asymptote. It's going to be very close. It's going to be coming in from very close. The asymptote will pull the graph towards itself, right? So I know it's coming like this. It's going to be getting closer and closer to the horizontal asymptote. It's going to be on the positive side. And watch what happens. I'm approaching this y-intercept also pulls. Okay. This y-intercept here is attracting my graph. So my graph will gravitate toward this y-intercept. So it's coming in from very close to the wall. It's going to reach my y-intercept. It's going to cross the y-axis. And then it's going to hit this wall. Remember, the graph will splash against this wall, but not touch it. Okay? And there it is. It's a bit messy right here. There. Okay? There's the graph in that interval from negative infinity to that wall at 1. Okay, now let's see what happens behind the wall. Behind the wall, it says here that the graph is below the x-axis. So that means here's my x-axis. That means I'm under here, okay? I'm in the negative side. which means that between 1 and 3, I'm going to be negative. What's going to happen at 3? At 3, since this is a 0, I will cross the 0, and that's what it says here. After 3, the graph will be positive or above the x-axis. So let's go here. Here we said that the graph is behind the wall, so it's going to be approaching this wall, very close to it, never touching it. And as the graph rises, it will be attracted to this 0. This 0 will pull the graph towards itself, and then watch what happens. It's going to be positive, okay? But I have a wall right here which it will approach, get very close to, but never touch. And there's your graph. I'm going to graph this in WZ Grapher, and we'll compare results. Okay, here's your graph using WZ Grapher. Notice that in this region we had said that the graph was above the x-axis, but also above the horizontal asymptote, which is right here at y equal to 4. This is an imaginary line that the graph approaches but doesn't touch. It can touch it. In some cases it will cross the horizontal asymptote. There it is. So you see how the graph approaches the horizontal asymptote, and then that y-intercept that we said there was a, let me scroll up. This y-intercept we said that happens at 12. Here it is, 12. There's a y-intercept there. It crosses, and then it keeps going up, okay? Just like what we drew. And behind the wall, we said there was a wall at x equal to 1, right? Which is about here. If we go down like this, we can see that there is an imaginary line here that the graph will approach but not touch. So here's that second part of the graph where it crosses the 0 at x equal to 3. There it is, x equal to 3. It crosses it. Now it's positive, but as it moves up, it will approach here, the y equal to 4 horizontal asymptote. Okay, so there's your graph. It came out pretty good compared to what I drew. It looks very similar. There it is. Okay, I'll see you in the next video for another example.